Okay, we're gonna create a new file. Select it. Oh. Okay, so we just created a new file. Make sure you opened it on Patron on the folder you had it in. We're gonna bring a Parasonic file. Make sure your units or tolerance are on base model. Then press OK. Once you imported the file, make sure it's an ISOView file so you could actually see the picture good. Now we're going to click on group, we're going to modify, and rename. The name we're going to apply is hex 8. Now we're going to apply, and OK. We're creating 3 points in a plate, and this is the tricky part. So we're going to geometry. We'll actually create point, extract. Turn off the auto execute and select. The 2 outside edges and make the outer radius and one of the bottom edges. I recommend you increase the point size, and now we're going to create a plane. We're going to go to object, and then plane. We're going to choose 3 points. Once we select 3 points, we click apply. And we're going to do it one more time, selecting our other set of 3 points. And we click apply one more time. So now we're going to edit the solid and break. So we turn off auto execute, and then we select the plane. And on the solid list, we select the first solid. On break plane, point list, we're going to select the top plane. We're going to file, group, create. And we're going to type on the name TET4. Then we're going to click apply. Now we're going to geometry. The action will be transform, the object will be solid, and the method is translate. For direction vector, our values for coordinates going to be 0, -10, 0. Then we turn off auto execute and select the solid list. Click apply, and then we're going to create another group. We're going to name it TET10. We're going to click apply. We'll click to geometry, and then we're going to transform, solid, and then translate. The direction vector changes, and it's 15, -10, 0. And we select the solid list and click apply. Now we're going to go to post, file, group, post. We select hex 8, click apply. We change the view. We go back to geometry and create object point with extract. For curve list, we're going to select 5 edges. going to geometry, create point, method, arc center. Turn off auto execute. In the curve list, we're going to select 2 edges. Then apply. We're going to change the object and click on plane. We turn off auto execute and select the 3 points that we want on the plane. We're going to edit solid break and we turn off auto execute. In the solid list, we select is a solid 6. And then the break plane list is plane 3. We're going to create our last point on the plane, so we go to create object point. The method is project. We're going to turn off auto execute, and on the point list, we're going to select the point. Once our point is down, we're going to go to plane and we're going to select 3 points. So now we change the action to edit, we go to solid, and the method is break. So we select the solid list, breakpoint, apply. On geometry, we're going to change the action to delete, and then object solid. And then for this case, it's 4 and 5, and then we're going to click apply. For the plane, we're going to change the object to plane. Now we're going to select all the planes on the solid and click apply. Now we're going to go to geometry, and now we're going to edit. We're going to solid, the method is going to be for the solid list, we're going to select the 5. Then we're going to click apply. Now we're going to home. We're going to look for the L so it could display the solid labels. Now we're going to mirror the solid. We're going to geometry. We're going to transform the solid with the method mirror. So for define mirror plane normal, we're going to select the 3 points that are aligned on the plane. then the solid selection, all solid, and then make sure to turn off auto execute, then apply. Now we're creating more groups. Now we're going to file group create. The group name will be hex 20. We're going to go geometry, the action transform, object solid, then translate. The direction vector is 15, 0, 0. The solid list, the solid list is all 10 solids. We're going to go apply. Now we're going to file group post. Now we're going to select all the groups and then we're going to click apply. Now we can see the 4 groups in display. Now we're creating a system. We're going to geometry. The action will be create. The object will be chord. The method will be 3 points. We turn off auto execute and we select the points that are selected in the video. We're going to go to group and post and select only hex 8. We're going to apply and cancel. Now we're going to go to mesh. We're going to create object mesh with the solid. And then we're going to do it with hex 8. For solid list, we select the hex 8 geometry, then click apply. We will repeat this process for the hex 20. For the TET4, we're going to group, post, and select the TET4 group. We're also going to create a mesh, but the topology, we're going to be TET4. The solid input list, it's going to be the one shown. And we're going to click assemble parameters. Select the old TET4, then click apply. For TET10, it'll be a similar procedure. But instead for TET4, we're going to do it for TET10. Now we're going to see the 4 groups. We're going to groups, select all groups, apply, and cancel. The action is verify, object, element, and text is boundaries. We're going to click apply. Once checked, we're going to change the action to equivalence. Object all, method tolerance cube. Everything's fine. And then we're going to click on apply. We're going to go to verify and click apply. Now we're going to geometry, transform. The object is a solid, and the method translate. Object, the vector is 15, 0, 0, and the coordinate famous is 1. Chord 2, we change it to 0, minus 10, 0 for the direction vector. Now we're going to create the loads PCS. We could change the view of it so we could have a better image. Now we're going to go back to loads. And then we're going to go to the field section. We're going to create a method with the PCL function. The field name will be sin underscore pressure underscore hex 8. And then for the coordinate system, make sure it says chord 1. And for the scalar function, we're going to insert sin parentheses 2. We have to do this for the 4 groups, so just follow instructions. Now we're going to load species. Now we're going to create object pressure, element, uniform. For the new set name, we're going to put hex 8. We're going to input data. The load species scale factor, 1000. And the pressure will be the one for hex 8. We have to do this for the 4 groups. So next, for our application region, we will select this will apply for both hexes. Fortet is a bit different, so stay close and pay attention. Okay, now we're going to create a displacement node. The action would be create, the object would be displacement, and the type node. For the new set main, we're going to put a constraint. We're going to input data. Our translations are going to be 0, 0, 0, then click OK. On select application region, we're going to click the surface or face icon and select the back part of all the form models. Click add, and then OK. Now we're going to define the material. We're going to properties. We're going to click on isotropic and material name. We're going to put aluminum. On input properties, we're going to put the one shown in the pop-out. Click apply. The property of this material will be a 3D. So on properties, select the one that says 3D solid. On property set name, we're going to put solid. And then for input properties, we're going to be the material which is named, which is aluminum. We're going to click OK. For the application region, we're going to select all solids and then click OK. Add. OK. Now we're going to check everything on loads is OK. So now we're going to loads. We're going to go to action, modify. We click on the fall and the pop out. All the pressures we created must appear. On scene, we click cancel. Now we're going to perform an entire analysis, so click on analysis, go to solution type, and make sure that linear static is selected, then click cancel, then apply. Click on text, then click select result files, then apply. Now we're going to the results tab, and in the results tab, the topic will be formation. So we select displacement translation. Now we go to display attributes. We remove the show tide and undeformed boxes. Now we go on the flat erase icon and then erase under geometry and then press OK. Back in results, we're going to create a range and we're going to look for stress tensor. Then we're going to click apply. Now we see the analysis of 4 groups. Thank you.